Hi everyone, and welcome to this webinar here for Octant, an open source project that gives you visibility into your Kubernetes clusters. My name is Jonas Roslin. I'll be your host today. With me, I've got Brian Lyles, who is the team lead for the Octant project here, and he will go through the project with you all. This is being recorded, and if you have any questions, you can either click on the raise hand button or you can type your question into the chat window and I will read it out aloud to Brian during the Q&A session. Brian, do you want to share the presentation with us?
Yes, let me get that started here. All right. All right, so today we're going to talk about Octant. Octant is a new open source project that we've been working on here at VMware. And the purpose of the project is to provide some visual abilities to explore your Kubernetes clusters. So let's get started. Oh, and by the way, I'm Brian Lyles. I lead a group that we are thinking about developer experience. How do developers fare in the cloud native space? So this is just one of the projects that we are working on. And this is my current team. We have Wayne and Sam who are also on the call as well. So back to Octant. What we did when we about a year ago, when we were thinking about projects in the cloud native space, instead of thinking of products, we actually thought of things that we would want to solve or problems we would want to solve for users. And a big problem that we were thinking about was, as a developer or anyone using Kubernetes, how do I know if something is going wrong? So what Octant actually started out was a troubleshooting tool. I have some kind of workload running in a Kubernetes cluster. Is it working correctly? Can I actually figure that out? And can I show a user of my software if their software is working as they think it should be? And over the last year, what's happened with Octant is we've been, first of all, figuring out what the core was, because Kubernetes was not made to do some of the things that we were doing with it. And also, we spent some time trying to make the user experience a little bit more robust, because just having a view of things in a cluster without context is not super helpful. So this is what has actually evolved from answering the question, how do I know if my software is running correctly? So I would actually like to get into demo super quick and make this super technical. So let me go ahead and do that. So Octant is actually a binary. And I have the version of Octant that we're getting ready to release today, and I'll be showing that to you. And one of the reasons we created Octant running outside of the cluster is because we want to make sure that we don't run into the class of problems where you have a piece of software that runs in your cluster that has access to everything and then trying to pare down that access. We're actually going the opposite way. We take your credentials and we interact with the cluster with your credentials. So there's never a chance that we can have privilege escalations because it's your privilege. So this is why Octant is outside of the cluster. And ultimately, what we would like to do is to convert this into a more operating system friendly application. So right now, you'll see in a second that I'll launch Octant from the command line as a CLI tool and then interact with it through a web browser. But really, the Octant feels like it should be an application, and it should be able to take advantage of things that come with your operating system, such as the status bar or your system trays, depending on whether you're on Mac, Linux, or Windows. And that brings me to the next point. Octant works on Mac, Linux, and Windows. We are trying to provide the same level of support across all three platforms. And so far, we've been pretty successful. So let's get into this demo of Octant. But before I get started, let me launch a web browser, because when it comes to Kubernetes, generally the Kubernetes piece is super interesting, but the thing about Kubernetes is it's there to solve problems for us. It's our vehicle for the journey. Kubernetes is not the destination. So really what we want with Kubernetes is we want to be able to run our applications. And I just happen to have an application. I worked really hard to find someone else's software. This is actually a piece of software called HTTP bin. And if you're doing any type of web development and you want to test things out, it's actually one of the best pieces of software out there. And the reason why is because it supports all of HTTP. You can test out posts, you can test out cookies, you can test out gets, and it's just a nice, simple piece of software that is great for testing. So my deployment to my Kubernetes cluster is this HTTP bin app. And just to show you, I'm just going to actually just show you this namespace, and we'll get to see it in a better way. This is what you get with Kubernetes. You can do a get all, and you can actually look through it. And if you understand exactly what was deployed and how it was deployed, you can make sense of this. But in a lot of cases, someone else deployed the software and someone else is responsible for taking care of it. So with Octant, what we're going to show you is that it does make it easier to see what's going on inside of your cluster. So let's pretend it's Friday afternoon at 5 p.m. and that one person on your team says, no, let's get this change out for the weekend, and they do a deploy. So I actually have a deployment here. We'll just call it release. And I'm not going to show you the YAML. It's not really important for this piece. But we did a deploy on a Friday at 5 p.m. And what happens on a deployment at Friday at 5 p.m.? Well, it breaks. And now we're in the place of, well, what do we do when our previously working or never working our application in Kubernetes is not working? Well, if you are a Kubernetes expert, or even someone who's just a little bit familiar with Kubernetes, what's the first thing you're going to do? Well, first you need to know what workload it is. Then you need to know how it's configured to talk to the external world. And the problem is that we assume that you have some level of experience that isn't really required for an application developer. So this is really why we invented Octant. So without further ado, I will boot up Octant. Like I said before, it's a binary and it runs as a web browser application right now. So I'm going to launch Octant, and actually I will make it just a little bit wider. So here's Octant, and this is currently, as of our 0.7 release that we're going to do soon, is the home page. And what we're showing here are a few things. It's actually just a dashboard. On the left is all the things you can see, and on the right is a expanded view of whatever you've selected. And the reason I'm being vague is because depending on what you've selected is what you'll see. So right now we're looking at an overview of the cluster, and or of a namespace in the cluster is 2019-08-918, and we can see all the objects that we think are important for here. So whether they be workloads or secrets or custom resources, we can show them all, same pane. So
hey, Brian,
yes.
Just a quick thing here. Can you zoom in a little bit?
Yes, I can.
Thank you so much.
Yes, actually, this is what I'll do. I'll make it full screen, and there we go. So yeah, just let me know if it's the right size.
I think you can go one zoom step in. Perfect. Thank you.
All right. So now, what the problem we're trying to solve is website doesn't work. So what do? So this is an interesting problem in itself, because there's not if you're not an expert or know how your application is configured, what do you do first? Well, with Octant, this is what we've done. So right now, what you can do in Octant is, we know that this is a deployment of some sort, but do we know exactly which deployment it is? Well, I can guess because it says HTTP bin is one of the name of my deployments. We can actually do that. But there's actually something better that we can do inside of Octant. We can actually filter based on labels. And the reason why you'd want to do this is because a particular workload in Kubernetes or an application might have a deployment. It might have a service and an ingress, might have more than one config maps or volumes or secrets. Depending on how many actually applications are running, there could be different service accounts, and there can be custom resources. So what we did is we actually put labels into Octant to allow us to zoom into what we want to see. And the reason I bring this up is because in the Kubernetes project, we worked really hard to define a set of labels that will allow you to figure out what an application is. So I don't actually have them labeled with that standard, but I do have this project HTTP bin label that we can actually use to narrow down to what we're seeing. So what I've done here is I filtered my view now to just only show things that are in this project :HTTP bin. And what you'll see here is it got rid of a lot of things, but now we see that in our deployment, in our workload or application, there's a deployment, an ingress, a service, and some kind of custom resource. And so now we have even a smaller surface area to actually figure out what is the problem. So let's go back to our error. It says the HTTP bin page can't be found. No web page was found for the web address. Well, actually, what does that mean here? So we know that Ingress is responsible for serving up websites or serving up basically hosts inside of Kubernetes. So let's go there first. And what I'm doing here is we'll just go to this HTTP bin, Ingress, and we'll see what it actually says. Because what we're looking for are clues to what the problem could be. And ultimately what we want to do with Octant is instead of having to look for the clues, we want to actually tell you what the problems are and then give you the easy fixes. So if we're looking through this, we can see that in Octant, we have a summary view that we've gone through, and we just distilled down Ingress to its important parts. So for every single object inside of Octant, you'll get configuration. Sometimes you'll get status. You'll get the metadata. You'll notice that I applied this with kube control. And because this is an ingress, we can see our rules, and we can also see the events for an object. So if we go through and look at the events, let's see what we see here. The first message says, error while evaluating the ingress spec, could not find service. And it says the service name is HTTP-BN. Well, that's obviously a spelling error. And you can actually see that right now with kube control describe. But the problem is that she would have to know how to run kube control describe. So we put another feature in Octant, which was the original feature. How do I know what's wrong? So what we have is this thing called the resource viewer. And what it does is it looks at an object, and then it looks at all the objects that our object is connected to, whether directly or indirectly. And it goes through that entire tree or that entire graph, and it actually builds up the state. And what we can see right now is that HTTP bin, this ingress is in red. It's in an error state. And what Octant is telling us is that a backend refers to service that doesn't exist. So that is the first clue of what is happening here. Now, if I go back to the summary, what we would like to do is have a way to edit our rules here, but Octant is still a young project, so we don't have editors for everything. So for a couple of these, I will go to the command line and actually edit them from the command line. So what I'm going to do is actually, I'll use kube control edit. And what I'll do is go down to my typo. And what I'm doing right now is I'm editing basically a manifest that's on the cluster, and I'm going to go fix my typo. So we edit this, and you'll notice that it actually happened pretty quick. In real time, what Octant picked up the new backend now, and what we're seeing is events come in real time. And this is the power of Octant. It's a real-time tool. You don't have to set polling periods or anything like that. We've set it up so that when things are changing, that we're telling the front end, whatever the front end might be, what's going on. So if we go to Resource Viewer now, we notice that, hey, my Ingress is now connected to a service, but my service has an issue now. And since we're still triaging this problem, we'll say, all right, well, what is this error? Service has no endpoint address. So in Kubernetes, your workload ultimately creates a pod. And what happens is whenever you want to send traffic, whether it's in the cluster or out of the cluster to a pod, you would use a service. And the way that the service works is that it matches labels from the pod to a selector that's defined in a service. So actually, let me show you how that actually works. So inside of the YAML, we have this thing called a selector. And in this case, it's run HTTP bin. So what it's going to do is look for pods that have the labels that match the selector, and then it'll build up these endpoints, and that's how it routes traffic. So what we've noticed here is that it says the service has no endpoint, and the reason the service has no endpoint is because, well, actually, I don't know why. Let me go look at the pods, and we'll load this. So what you're noticing is that it says that we have no pods. What Auxin is doing in real time, because the Kubernetes API doesn't have support for this type of interaction, is we're building up these query things called informers. And what we're doing is for every single type that we want, we connect this informer up. And what it does is it watches a particular resource in the cluster. So in this case, what it'll be is we're looking at pods. So let's actually have a look at our pods here and wonder why we don't have any pods loaded. So, oh, I know why this is. The reason why is because I didn't set up my deployment to propagate my labels. My bad. So when we go down to here, we can actually see that we have a pod that's called HTTP bin, but we notice the label on it is app HTTP bin. And if we remember earlier back on our service, it was run. So now there's an issue. And let me show you how we would fix this with Octant. So we go back to my service, and we'll go to this service again. And let me go down here. So if we look at the service, this service is set up to talk to this selector, and this is the wrong selector. There's actually nothing connected. There's no pods that will answer to the selector. So what we want to do is we want to be able to do this inside of Octant. I want to be able to edit and not have to use kube control, describe or get or edit or any command, because we want this tool to make kube control fit in the graphical world. We don't want to replace it, but we want to make it better. So now what we're doing is we can actually just go look at all the selectors that we have. And the editor here is very simple. And we're going to actually just change it. We can actually choose multiple ones, but we only want one. So now we're changing our selectors for our service to app:/HTTP bin. And what you notice now, there's an endpoint that now shows up, and it matches our one pod. And we can verify this is working now. Well, our graph, it looks way different. And now what we can see is that we have an ingress, and our ingress is connected to some kind of some custom resource, which is connected to another custom resource. We have an ingress that's connected to a service, which is connected to one or more pods, which is connected to a replica set, which is connected to a deployment. And the pods are also connected to a service account. And we use this information to determine if things are working correctly. So if I go back to my original page and I hit reload, it shows up. Because now we have this graph, and the way that we know that it works is because we can verify it in real time. And let me show you another feature of Octant here. and show you this whole real-time thing. So what I'll do is I'll edit, I won't edit that. I'll edit I'm gonna edit the service just by hand real quick, just to show you that in real time that this tool is actually doing that. So we'll go back to run again. And what we'll see in real time, no changes, that it actually does all the things here. So we'll edit it, we'll change it back now to what we know should work. And oops, there we go. And there we go. So now our site is working. So what I'll do for the next couple of minutes is I'll walk through other features that are inside of Octant. It's more than just showing items in a dashboard, and we have this resource viewer. So before I was saying that we have YAML. This is just the YAML this is just the object, in this case, a service called HTTP bin that we rendered as YAML. So you can actually see the configuration, because there's items in the summary that don't translate well to our components that we have here. So we want to make sure that you have everything. And specifically, those would be things like some of the status items. So service is a bad one, but we can actually show you everything, at least how the cluster sees it. So you'll notice that we have summary, resource viewer, and YAML. Let's actually go check out some different objects. So let's look at a pod. So this is the pod that is serving the container that has our website. There's a couple things interesting on this page. So same thing. So we have summary, resource viewer, and YAML. But another neat feature that we can add here, per type, we can add other tabs. So for a pod, we also might want to see logs, because containers have logs, and you could use the kubectl logs command to get this out. So what do the logs look like? Well, they're just the logs that the process started. So this is a very simple log viewer right now. We're reading it right off the API, and we can show it with or without a timestamp. Future ideas for this page is we're going to add support for different types of logs. So I know a lot of people are logging in JSON, and we should be able to support that here. And another thing that we're going to add is being able to see logs across multiple pods at a time, which would be interesting if you were running more than one pod, so you don't have to actually go search. Other things that we have, if we go back to pods, are port forwards. And if you can remember the way to start a port forward, it's kubectl port -forward, and then then when you type next, so maybe it's the service, the deployment, or the pod name, and then is it local port first or remote port first? Well, you know what? I don't want to remember any of that. So now, if you have a service or anything, or if you have a pod with a container in it, and the pod actually defines its container ports and it's TCP, guess what? We can give you that right in the browser. So what we're doing here is I'm starting a port forward, and I'm starting it on your local host. So it doesn't matter where the cluster is running. I can actually just show you locally what's happening on that port. So in this case, I've actually started a port forward on localhost 61534. So when I click on it, we get the same view, but this is actually using the port forward. So if this was a remote cluster, I could actually see it like it's local. One thing that we're going to do for this is that right now we only support services. You'll notice that kubectl supports, like I was saying before, it supports deployments and services as well. And the reason that we're not is because the way that kubectl does it, it's indeterminate. What happens is it says, give me a service, or give me a pod for a service, or give me a pod for deployment. And and there's no way inside of the Kubernetes code to track that, what actually is getting port forward, because you're not port forwarding to a deployment or service. So we're going to work on getting this in the tool so we can actually track it. And we want to be able to track it actually elsewhere in the application, and I will go there right now. So what we can do is, since we have the port forwards, we can track all the port forwards you have going at one time. You can actually have multiple port forwards going, and then you should be able to control them from one location. And this will be super helpful whenever we do it with services and deployments. So moving on here, there's other interesting parts. We've broken up Octant Views into multiple main views. So there's an overview, a cluster overview, and a configuration. So inside of Kubernetes, there's namespace scoped objects. The objects you think about are like services and pods and service accounts and config maps. And then we also have cluster overview. These are the cluster scoped objects. So in our case right here, you have some RBAC, whether it be cluster roles or cluster role bindings, but you also have things like nodes. And another thing you would have are your cluster scope resources. So what we can do is we can show you this. And this is actually another interesting tool or piece of Octant that we don't see out there a lot, is first-class support of custom resources. With kube control, I think ever since Kubernetes 1.12, maybe 1.11 or 1.12, you were able to have custom printers. And because you could have custom printers, we could define our custom resources and we could create custom printers. So what you'll notice here is this is a list of cluster issuers. Octant knows literally nothing about cluster issuers. All it knows is that it's a custom resource and it doesn't have a custom, it doesn't actually have a custom columns. So all Octant can do with it is say, well, I know it has a name, I know it has labels, and I know it was created at a time. So whenever Octant does this, what we can do is we can kind of guess at what we think is actually in the object. So we don't know anything about config, but we can definitely show metadata. And that's kind of neat. But a very neat piece of Octant is that we can show more information if the CRD actually has more information. So you'll notice that this custom resource for certificates has more columns. None of this is baked into Octant. It's actually baked in the CRD. So what we can do is take the custom column information and we can apply some logic to it. And now what we can do is generate views that have a little bit more information in there. So we can figure out kind of what's configuration or it's kind of what status is. So what this does is, just out of the box, it allows Octant to have this neat information about custom resources and CRDs. But we can do one thing better. And let me actually show you this. I didn't turn it on when I first booted the app because I wanted to talk about other things first. But what I'm going to do is I'm going to install an Octant plugin. And I'm not going to tell you what it is before I do it, but we actually have support for extending Octant. Like I was saying before, Octant can only know about things it knows about, and CRDs are custom, so there's no way that Octant can know about CRDs. So what we can do now is we actually have a way that we can extend Octant without extending the binary itself. And what I did real quick was I installed a plugin, and this is just a sample plugin, and what it does is a few things. First, for pods, what we can do is we can extend the information that we're showing. So before, when we had a pod, we had summary, resource viewer, YAML, and logs. This plugin is an example plugin, so it's actually just showing the power of the plugin interface. Well, now what we can do is we can actually we can change configuration. So from the plugin, we can make real-time updates. And I made this a number. I made this an increasing date so you can actually see a change. We can actually change status as well. So we can say that there is extra status that I know from my custom object or from an internal object. I can print that as well and have it show up in Octant's interface. And another thing that we can do is we can actually just add extra output. So we can add extra output from a plugin that makes it look like it's built into Octant, but this is coming from the sample plugin that we just installed. And likewise, I was showing up here earlier, we can do things like with extra tabs, we can just put content, and this content can use the same widget set that everything else is using, but it's running in its own external process. And another thing that we can do is we can add a whole new menu. So what we did here is we just added a whole new menu. So if you had a service where you were doing something like this custom CD, some continuous delivery, we could integrate this tool right here in the Octant. So we can show your tool's output, but we can also show it in the context of what's happening to the cluster. And I think that's missing for a lot of people. So in this case, we just happen to have an extra tab that we put in the plugin, and the tab can change values. So just a very simple example. So Octant is built to help you see what's going on in a particular cluster, but it's not limited to what it knows. We can actually make that knowledge much more, we can make it much nicer with this plugin interface. So let's see what else we can do with Octant. And this is actually stuff that's coming in our next release, our 0.8 release. So let me show you some more, few more things about Octant, and then we'll turn it over to roadmap and Q&A. So we want to be able to not have to use kube control edit. I mean, this is only if you're in a development cluster, you don't have to use kube control edit. So what we've done is we're experimenting now with editors. So for a deployment, for example, I want to be able to scale this deployment up. So what I'm going to do, and actually I'm going to change it to a different deployment. So something I actually know the Docker image names for. And the first thing I'm going to do is I'm going to scale this Nginx deployment up to 5 replicas. And what's happening now is in real time, I scaled my replicas. And the neat thing about these menus is that even if you were doing, you can actually add these types of menus from plugins. So we're adding basic editors, but you could actually change this editor to edit more complex things. And there's also other things that we can edit as well. So in a pod template for a deployment, there's containers. So one thing we can do is we can say that this is our app. We wrote Nginx, and we want to actually change the version of Nginx. So now we'll just change it to, we'll do 1.15. So we'll say that we've moved Nginx to 1.15. So from the actual app, we actually were able to do this. And the neat part about this is that it's down to the bottom, so we can see in real time what the cluster is doing. So it's scaling down a replica, and well, first it created a replica, and then it started moving one object from one to another. And what we can see here is if I go to the resource viewer, everything is up, but this replica actually is brand new. And to help with that view, another thing that we're going to do, and this will actually be part of this, will be in our next release as well, is that we want to change how people are looking at Kubernetes clusters. We are so used to looking at dashboards, we default there. But I think that if we could rally around a view like this, put the good information towards the side, have simple views, have simple editors, a lot of the work that we would do with trying to work with our Kubernetes clusters can happen from a screen like this. So I could have a deployment editor right here on this screen, and in real time, we can see how it is changing my cluster. And if it breaks, then we can have the alerts come right here on the screen at the same time. So this is where we'll end for this bit. There's other views in here. So every type that we have in here has its own view besides custom resources. And what we're working on now is, now that we have a foundation, is making these views better and making them more useful to our users. And We also are listening to our users. Someone came in a couple weeks ago and said, I want to see nodes. So nodes show up. And now you can actually get a view similar to what you would get if you did a kube control describe node. It's not 100% because we haven't put in pods yet, but that will come pretty soon where you'll actually be able to see the pods that are running on a particular node. So I will stop demoing this now and I will go back 2 slides. The next item is our roadmap. So before I talk about the roadmap, let me talk about what was going on with Octant in our next release. We are preparing a 0.7. We're Octant 0.6 now, which is our latest release. We're preparing a 0.7 that's coming very soon. We're almost there if we don't define any more bugs. And the difference between Octant 6 and Octant 7 is 0.6 was our first public release. It's where we showed it to the world. 0.7 is a lot of feedback from a lot of people where they are finding bugs that we wouldn't find. Things like how we were handling CRDs. And it's nice having the diversity of people, like a huge diversity of people looking at this, because there's lots of corner cases that we didn't see. So in 0.7, what we've done is we've actually made multi-cluster useful. So something I didn't show you was we're on a cluster that I just call it GKE cluster 1. It's just a cluster that I have running on GKE. You can actually swap, and my kube config isn't set up correctly, but you can actually swap if you have multiple kube config locations, and then you have multiple contexts. Octant can swap in between those. So that's a pretty neat feature if you actually have to work on multiple clusters, or if you work on a cluster where you have a read-only view and then you're moving to a read-write view for safety. So that's a good feature. The biggest feature of between 0.6 and 0.7 is how we do the backend. If you notice, this all looks pretty seamless, but there's a lot of stuff happening in the background to make these views show up correctly. And before we were using HTTP long poll to get the information, but we were finding that if you do that, you have to keep a lot of data in the front end. And I've showed you a web GUI, but there's no reason why there isn't other types of front ends for this. Maybe integrate it with your favorite editor or integrate it somewhere else. So we've swapped the backend to a WebSocket backend. It allows us to have asynchronous communication, but it definitely allows us to move all the complexity in the front end to the back end where it's actually easier to maintain, which makes it easier to write front ends. So that was a huge change in this segment. And then we also added editors. Moving forward, we actually do have a roadmap for Octant, and I want to highlight some of the important pieces that I think. The biggest one is viewing and editing your Kubernetes objects. I want to have the same fidelity or even better fidelity than editing objects than when you get with kube control edit. As you saw before, I did an edit and I ran up the command line. It launched my editor, which was Vim, but you had to know what to change. I want to be able to show you what you can change and then give you inputs for that change if possible. Another thing that we want to do is we realize that the YAML editor is important, but we want to be able to make that a better view. So in the editor, whenever you're looking at the editor, I want you to be able to see things like, we have pod cider. Well, what does that mean? In the Kubernetes API, there's docs. There's a lot of documentation for what this pod cider is. We should be able to show you that in real time, inline. Other things that we would like to do is extend the plugin API. I showed you a little sample of it, but we want to actually make it robust so people can write cool things on top of this. Google has a project called Tecton, which is a Kubernetes aware continuous delivery tool. And they wrote a plugin for Octant. And I want to be able to enable a lot of people to write plugins for this because we are more of a journey tool we want to be a part of whatever you're doing, but we can't know everything about it. And in certain situations, like with your editor, if you use VS Code, you don't need a Go extension if you only write Python. But because VS Code has the great editing experience and the great extension experience, we can actually provide that feature, and it works. And we can do the same thing with Octant. And another item here is speeding up Octant. I mentioned before a little bit about how we're using informers that are in the Kubernetes client to actually talk to Kubernetes. It's not real time. It looks kind of real time-ish, but we do a lot of tricks to make it feel real time. And there's things that we can do to, I think we can do more in Octant to make it even feel even more real time and reduce memory usage at the same time. And the last piece here, and this is the most important one to me, is I want to make sure that this is an application. I want it to make it feel like it's part of your desktop. When it's in a web browser, it's interesting, but we want to make it feel like it's a real application. So with that, please take a look at the rest of the roadmap. And what I'm going to do now is, if there are any questions, I'm here to answer them for you.
Awesome. Thank you so much, Brian. Do you want to put up the slide where people can get involved with this?
Yeah, let me do that. Let me share my screen again here. All right, so share this one. Go back here. Yes. That reminds me, before we get into the questions, I do want to say a couple more things. This is where our project is. We're at VMware/Octant on GitHub. We have a Twitter and we have a Kubernetes Slack, and someone from my team is always there. So we are there answering questions and helping people get started. And we do have a mailing list. But the most important piece is if you want to be involved in this community, we are trying to build it. And we have a meeting on every second Tuesday right now. And I think the next meeting that makes it the 8th of October. We are definitely accepting pull requests. This is not just a project that we open the source for. No, we are accepting pull requests from people, and people are sending pull requests. So please come look at what we're doing. And now I really will end.
All right, awesome. So we do have a few questions here. The first one is from Eric DeWitt. He tried Octant from a customer laptop today. kubectl is connecting fine to the K8s cluster. He started Octant, the web portal opens but doesn't show anything. Does Octant use a special port to connect to K8s, or is there any logs he can check?
So I would most likely guess that you're using Octant 0.6. The 0.7 was the, I would almost be sure of whatever you were running into, and there's a few things that you could be running into, especially if they're running CRDs, that you could have ran into. Our next release should solve that issue, because right when we released it last month, the first couple of ones where I'm getting CRD errors and it's not connecting. I'm having this issue. And what we found is that people were creating CRDs that Kubernetes would tolerate, but they weren't actually correct. And what Octant was because we were so strict in how we were parsing them, we would just bail out and then not show you anything. I don't know if that was the right answer, but that's where we were. The real answer to this is if you run Octant with -v, it turns into verbose mode and it'll show you a lot more stuff. Please either send us on the mailing list or come into our chat or create an issue, and we'll help you get through the problem.
Excellent, thank you. Next question here from Tom Otomansky. Any chance that Octant will support multi-cluster connections in the future?
Yes, there is a huge chance that Octant will support multi-cluster connections in the future. So the reason it doesn't now is because it's an easier problem to get started by connecting to one. To make it support multiple, we're actually going to have to change a bit of our core, because this is the way that we work with it. But there's nothing there's no technical reason why we can't do this. We're going to try to figure out when we're going to get it prioritized, but it's definitely on my mind and Wayne's mind right now. And
Awesome.
the other answer is you could just run 2 instances of Octant. And you'd have to change the port, but that will get you through right now. But we want to have a better experience than that.
That is very true. All right, next from Eric Cardy. Will PVs be viewable in the future?
Will PVs be usable in the future? Yes, create an issue. What we did was, and when I started this, I did a survey of what was going on. When I just took a survey of what a few UIs were doing for a dashboard, and we picked the most popular ones. Having PVs viewable, yes. And also someone else earlier today reached out about network policies. We'll try to make them, PVs will be easier to actually show, but we'll try to get those objects in, but let us know whatever else you want to see. Now, and then I'll just read the next question because I have an answer for it. And since I'm already talking, Eric asked again, he says, does Octant run in a Kubernetes cluster? Will we be able to view the corresponding resources in Octant? So when I first started this, I mentioned that we prefer to have Octant run locally with your local credentials. That does not preclude you running Octant in a Kubernetes cluster. We actually have a Docker file. You could actually build a Docker image. We're not supporting it right this second. And you could create a deployment, and you could deploy Octant to your cluster. I've done it for an internal team, and it does work. There are a couple of gotchas that we're working on now, or we're trying to work out now. But yeah, you actually could run Octant inside of a cluster and share it with multiple people. Go ahead, Jonas.
Awesome. Yeah, next one here. This is just a little more fun. Regarding the Octant logo, was an octagon considered instead of a heptagon?
I write software. I don't know the real answer for that. I don't know the real answer for that.
Sounds good.
Yeah.
Let's move to the next one. Can Octant, this is from Bipin Jethwani. Can Octant run on a headless Linux instance, and I use a browser or another machine to access the GUI?
So I gotta see how we create the listener, but it shouldn't be impossible. If we can't do it, it's a one-line change to make it work. We could, but I don't know out of the box. I don't know if I think we let you set the port, but we don't let you set the host, and we pin it to localhost. So it's possible. Actually, it would be great if you created an issue for this. That's way so we don't forget it and we can get it prioritized. But I don't see a problem with that, especially if you want to run it on a headless Linux instance.
Awesome, thank you. Next one is from Vladimir Vivian. Storage visibility via CSI would be great. Are there any plans to incorporate that?
We don't have any plans to, and I will say the first thing, I am not an expert at CSI, and I don't even know what we would show. So what we would need to do is first determine, do we want this in core? We probably could put this in core because it's CSI. And we would need to collaborate with somebody to help us understand what that view would look like. And so I'm encouraging you, Vladimir, to reach out. We can definitely do that.
Awesome, thank you. And then the last question here is from Jeremy Moffett. It's a non-technical question regarding the CLA. Jeremy, I can take that offline with you. So just reach out to me on the Kubernetes Slack and we can get that sorted. Let's see, I think that's it. No more questions here in the chat or any raised hands. So I think that means that we are done. Do you have any parting words, Brian?
I want to say that I am super happy about all the great feedback we've received from this project. When Joe Beta and I talked about this, Joe Beta, the creator of Kubernetes, we talked about this about a year ago, like literally a year ago, and I thought it was going to be a good idea. He went off and did other things, like sold Heptio to VMware, and I worked on this. And it's great to see that people are seeing it from the way that we're seeing it. And we're just getting started on some of these amazing things that Octant can do. And I really think that if we get it even halfway right, we'll change how organizations and groups of people are adopting Kubernetes, because we're making it accessible. And so we are so at the beginning of this right now. It's crazy.
Awesome. Thank you so much. We actually do have one more question from Vivian, so I'm going to allow him to talk here. Vivian, you can unmute yourself.
Sorry. Can you guys hear me?
Yes.
Yeah, so quick question. You know, being in the industry for so long, I've seen tools like this that has grown up to be very, you know, adopted all the places. Now, the question I have is, do you foresee Octant doing things like allow you to deploy, not just a reporting tool, but an active tool that allows you to deploy resources onto the cluster as well?
No.
No, okay.
No, that's why we created the plugins. We never want to do that.
I see.
We want to be a view tool of understanding Kubernetes objects, how they get there. You might have an editor. We might put in a feature, actually I prototyped one the other day, where you could actually go to Octant, say I want to import a manifest. We will load the manifest for you and then disseminate through it, split the objects out so you can actually see what you're putting in your cluster. And then before the 1.7 or the 1.16 server-side apply, so for 1.16 and 1.17, when we don't even know if server-side apply works well, we can do something where we can do a simple thing where we can apply your objects and we'll just do CRDs first. But that's about as much as I can ever see. We would actually rather integrate with figuring out what Helm support for Octant looks like, or working with like Tilt or Garden or Scaffold or Tecton or any other myriad tools that we could think of.
Okay, that makes sense.
I'm not trying to put everyone out of business.
just some, right?
Yeah, just some of you.
All right, thanks, man.
All right, no problem.
All right. I think that's about it. And thank you so much, Brian, for the presentation today. Really, really appreciate it. And thank you so much, everyone who joined in for the webinar. We will post this up on YouTube later today. So if you missed anything, you can watch the recording. You can share it with your colleagues, friends, and family. And with that, thank you all and have a wonderful rest of your week.
Thanks for coming.
Have a good one.